Welcome to Bednik Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share.
We also have a Telegram channel where you can communicate with us, ask questions and meet with other educators. The link of our Telegram channel is in our YouTube bio and comment section.
Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand further math. That is a spirit. Bednik Tutors. Excellence is our watchword.
Hello, my beautiful people. Welcome once again to Bednik Tutors YouTube channel, a channel where we expatiate science subjects, in a way that you will understand. Oh yes, our videos are too much, but we want you to have a better understanding of each topics in science subjects and also junior mathematics. Oh yes, and we advise you that to watch all our videos even to the very end. It is very advisable that you do that even before downloading it. And if you have to watch what you want to download, do you understand? Please do well to always watch our videos and text everyone who subscribe. You need more subscribers. Please try and share to your friends and family. Thanks very much. And also please do well to join our Telegram channel because we want you to ask us questions. We want to answer your questions. We want to know what is bothering you. We want to know the questions that you have, and we're there to answer you. Do you understand? So the Telegram link is in our YouTube bio. Okay. All right. So that is that for now. So now this is binary number system part 3. Thanks to everyone who watched the part 2 and part 1. So this is the part 3 now. So now I promise to move to multiplication and division. But before I move to that, let's quickly do this example. Do you understand? So let's go. Find the missing number if the addition shown below is in base 5. So now let's see. So we are asked to solve this now. So we have to find this missing number. Get it now. And they are all in base 5. Get it now. So the thing we are going to do is this. We are going to first add up this 3. You understand? When we add up this 3, whatever we get, we subtract it from this answer. Do you get it now? So let's do that now. So let's add them up. They are all in base 5. Get it now. They are all in base 5. So let's add them up. 1, 2, 1, 3. 1, 1, 2, 1, 1, 0, 0, 2. 3 plus 1 got 4. 4 plus 2 is 6. So I tell you that when a number is equals to or bigger than the base, the base, you are going to divide it. You get it now? So now, let's go. 6 divided by 5 is 1, remainder 1. 1 divided by 6 is 0, remainder 1. So we have what? 11 here. So we have 1. We raise this one up. 1 plus 1 is what? 2. 2 plus 2 is what? 4. Do you get it now? So if 4 is less than the base, which is 5. So we are going to put that here. 2 plus 1 is what? 3. So we are going to go. 1 plus 1 is 2. 2 plus 1 is what? 3. So we are good to go. So this is what we got. So we are going to subtract it from this one now. So let's do that now. We have 1, 0, 3, 2, 3. So let's subtract it. So I told you start from the back. 1, 4, 3, 3. So it is very simple. They are all in base 5. Don't forget. So 3 minus 1 is 2. So 2 minus 4 is impossible. What will you do? You are going to borrow 1 from here. So it is possible since there is no 0 here. So when we borrow, I think that is the base we are borrowing. You get it now. So when we borrow from here, this one turns to 2. So we are going to move the base here, which we borrowed from this one. You get it now. So we have 5 here. 5 plus 2, 7. 7 minus 4 is 3. So now we've already borrowed from here. So when you borrow from here, it will mean 2, right? So now 2 minus 3 is impossible. So when you borrow from here, it is 0. So it's not possible. So we move to this place. So you can borrow from this one now. So you borrowed what 5 from here. So when you borrow and you move it here, so it is 5 now. So where, because we need it here, you still move this 5 to where we need it. I think that is the base we are borrowing. So this one will turn to 4. This will turn to 4. This will turn to 0. You get it now because this is 1. So this is 1. So because we borrowed from here, so this one will what? Minus 1, which is 0. So we have 5 here now. So 5 plus 2, not 3 again because we already subtract from here. So 5 plus 2 is 7. 7 minus 3 is 4. So we remain 4 here, right? So 4 minus 3 is what? 1. And this one remains 0. So we can't do that. So we leave it that way. So that's the final answer. So the missing number is this. Do you get it now? So this is our final answer. It's as simple as that. So if they give you in this one in school, you'll be able to solve it. It's very easy. Just add up all these ones, add up these ones, then wherever you get to subtract it from the answer, which is this one. And that is how to go about it. So now let's move fast now to multiplication and division. Alright, so now we have to find the product of 1101 base 2 and 111 base 2 with this one. We're talking about products, we talk about multiplication. Do you understand? So let's do that now quickly. So we have 1101 base 2 and we have 111 base 2. So now let's multiply. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. So let's go to the second one now. Just take it step by step. So 1 times 1, we put it here. You understand? The second line here. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. Have you seen that now? So now let's go to the third one. So the third one now, we're going to put it here. So just like steps. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. So let's add them up. So this one is in base 2 now. So when this number is equals to 2 or more than 2, you get it now. So we are going to divide the number by base 2. You get it now. So let's go. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 2. So it is what? Equals to the base. So let's divide it. 2 divided by 2, 1. And that's 0. 1 divided by 2 is 0. And then 1. So we have 10. So that's the 0. Have you seen it now? Since we have 10, so this is 0, we bring it here. And this remaining one, we raise it up here. So 1 plus 1, 2. 2 plus 1, 3. So now 3 is more than the base. We're going to divide by the base. 3 divided by 2, 1. And then 1. 1 divided by 2 is 0. And then 1. So that is what? 1, 1. So this one, we raise it here. So the remaining one, we raise it up. Simple. So 1 plus 1 is 2, 2 plus 1 is 3. So already know what 3 means. It means 11. So 1 here raised to power 1. Do you understand that? So 1 plus 1 is 2. So you know what 2 represents. It represents 10. So just write it here. That is all. Put your base. Simple as that. Have you seen? So let's go to the next one. This is how to go about it. 1.01 times 1.1. So just let's remove the decimal first. So once we remove the decimal, it is when we get the final answer, you now include the decimal points. So don't worry about that. I'll tell you how to go about that. This is 11. So we've removed the decimal now. So let's multiply. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. Do you get it now? 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. So we are done with that. So 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 2. You know what to represent? It represents 10. So put your 0 here and raise the remaining one up. So 1 plus 1 is 2. It represents 10. So that is that for that. So now the decimal. We have decimal before this one here. So this is 1. We have decimal before these two numbers. So this is 1, 2, 3. Do you get it now? So the numbers that comes after the decimal point and the numbers are going to count the digits. So that's what? 1, 2, 3. So let's count 1, 2, 3. Then we put our decimal point here. Do you understand now? So that is how to solve it. You get it now. So if adventure we have another one here, another one here. Now be 1, 2, 3, 4. So you count 1, 2, 3, 4. You put your decimal point here. I'm so sure that is well understood. So now let's do this one. I didn't put it here, but let's quickly do it. So now we have to multiply 202 base 3 by 211 base 3. So let's do that now. So you permit me to erase this page. I want to write it on the upper part. So it permits me to erase this. Alright, so we have to multiply 202 base 3 by 211 base 3. So let's do that now. So this one is different from the 1 stuff. So this is 211. Now 1 times 2 is 2. 1 times 0 is 0. 1 times 2 is 2. So let's go to this one now. 1 times 2 is 2. 1 times 0 is 0. 1 times 2 is 2. Have you seen it now? So let's go to this one. 2 times 2 is 4. So now you will not put your 4 here. Why? Because it is more than the base, which is 3. So what will you do? You will come here, you divide by 3, which is the base. 4 divided by 3 is 1, remainder 1. So 3 again, 1 divided by 3 is 0, remainder 1. So that is 11. Get it now. So you write it here. Get it now. So 2 times 0 is 0. So you put that remaining 1, you put it here. 2 times 0 is 0. 0 plus that 1, you put it here. 1. Do you understand now? 2 times 2 is 4. You get it now. So 4, we already know what 4 is, which is 11. So since we don't have any other number next, so we just write it here. I'm so sure you get it now. So that's how you are going to solve this. Okay, so we have 2 plus 0, 2. 0 plus 2 is 2. 2 plus 1 is 3. I told you that when it is equals to the base, or it is what? More than the base, you are going to divide by the base. So this is the base. So we got 3 here. So we divide by the base. 3 divided by 3, 1, remainder 0. 3 divided by 1 is 0, remainder 1. So that is 10 there now. So this is 0, remainder 1. Have you seen it now? 1 plus 2 is 3. 3 plus 1 is 4. So you know what 4 represents? It represents 11. Have you seen that now? So this is 1 raised to power 1. 1 plus 1 is 2. So we can go on with that. Then we have 1 base 3. So it is as simple as that. So that is how to solve this. If you have any question, do write to the comment section below. Can I even explain to you? You understand? Theoretically. You get it now. Alright, so let's now move to division. Now I want to move to division. So division is the next thing. Alright, so what we are doing next is division. So we are done with multiplication. So we have moved to division. So the way we're doing division is different from the way we're doing multiplication. So just watch me carefully. Now, so this is how you solve it now. So you put the bigger number here, 100. So now we go with this one now, which is what? This one is bigger than 100. So let's go with this one first. So if it goes, it will be 1. If 111 divided by 100, if it is possible, it is 1. If it is not possible, just put a 0. So there's nothing like 2 or 3. No, you understand? So 101 can divide 100. So it will just put your 1. 1 times 100 is 100. So let's subtract it. 1 minus 0 is 1. 0 minus 0 is 0. 1 minus 1 is 0. So you don't need to put 0. So bring this 0 here. Bring it down here. Do you get this now? So 10 divided by 100 is not possible because this one is smaller than this one. So just put a 0. 0 divided by 100 is what? 0. Do you get it now? So 0 minus 0 is 0. 1 minus 0 is 1. So bring down this 0 here. So you bring all this, if you're bringing down these digits after you subtract them. Do you understand? So 100 divided by 100 is what? 1. So 1 times 100 is 100. So when you multiply them, you have the 0. So that is our final answer. It's as simple as that. So let's solve the second one now. This is the first one. So this is the second one. As I've said earlier, the bigger one will be inside. 1100101101. Have you seen it now? So now let's see. 110. Can it go? No. So let's add this one. Let's pick this one now. Okay, sorry, it is 41. So now 110 cannot go because it's smaller. Then this one too is also smaller. So let's pick this one. So we have 11001. Do you get it now? So this one is bigger than this now. So we can divide it now. So when you divide this one by this, it's bigger. So you can just is 1. Just put your 1. 1 times this one, you get, start from the back. I told you when you are subtracting, start from the back. So you subtract it now. 1 minus 1 is 0. 0 minus 1 is impossible. You can't, if you borrow from here, it's not possible. So you just borrow from this whole number. I told you that it's in base 2. Do you get it now? It's in base 2. This is in base 2. So now we borrow 2 from here. We move it to this place. So when you borrow 2 from here, because this is 1, so 1 minus 1. So you remove 1 from this one now. So 1 minus 1 is 0. So this one turns to 0. Do you understand? So when you borrow 2 from here, this is not where we want to use it. So we need it here. You get it now. So you bring this 2 here. So when you move this 2 that you borrow, when you move it to this place, this one turns to what? 1. So this one turns to 1. You get it now. So 2 minus 1 is 1. Have you seen it now? So this is 1 remaining now, okay? 1 minus 1 is 0. So I told that this one remains 0, okay? So now 0 minus 1 is impossible. What will you do? You borrow 1 from here. You get it now, which is what? The 2. And when you borrow 1, this one, when you borrow this base, which is the 2, this one, you move it to this place, which is 2. So now, when you borrow, this one reduce and becomes 0. So now, 2 minus 1 is 1. Get it now? So that's for that. So you bring down this what? 0 here. Bring it down here. Have you seen it now? So when you bring it down, let's see if it can go. So 1 0 1 0 0. So we have like up to 4 digits here, but we have, okay, we have 5 digits here, we have 4 digits here. So it can divide. So it is 1. 1 minus this is still 1 1 1 1. So let's subtract. 0 minus 1 is impossible. So you borrow from here. When you borrow from here, this one turns to 0. So this is 2. So when you transfer it, this becomes 2. This one turns to 1. So 2 minus 1 is 1. So this one is mainly what? 1, right? 1 minus 1 is 0. So now, since you borrow from here, this one is what? 0. 0 minus 1 is impossible. So you borrow from here, this one turns to 0, 2. So when you borrow and you move to this place, this one turns to 2, and this one turns to 1. So 2 minus 1 is 1. So this one remains 1, okay? 1 minus 1 is 0. So this one is 0 already. So don't need to write down. Yeah, so when after subtracting, you bring down another digit. So let's see if it can go. So we have 1 0 1 1. So but 1 0 1 1 is less than this one. So it cannot go. Just put your 0. 0 times this one is 0. So just 1 1 0 1. So when you subtract them, this is what you get. And you bring down this to 0. Are you seeing it now? It's as simple as that. Just take your time. So this one have how many digits? This one have 5 digits. So now, since you have 5 digits and this one have 4 digits, it can go. So you can divide it. So 1 times this one is 1. 1 1 1 1. So let's subtract. 0 minus 1 is impossible. We borrow from here. This one turns to a 0. So we have 2 here. 2 minus 1 is 1. 0 minus 1 is impossible. You borrow from here. This one turns to 0. Get it now. So this one becomes 2. So 2 minus 1 is 1. So we have 0 left here. 0 minus 1 is impossible. When you borrow from here, it's not possible, but we can borrow from here. This one turns to 0. So this is 2 now. 2, when you transfer it to this place, this one turns to 1. So this is your 2. 2 minus 1 is 1. So you already borrowed from here. So we have 1 here. 1 minus 1 is 0. Get it now? So you can just leave it there. So you've already borrowed from here. So don't need to add a 0. Then you bring down this one here. So now we are left with 1 1 1 1. So 1 1 1 1 divided by 1 1, it can go. So that is it. So 1 times this is what? 1 1 1 1. So this is 0. It's as simple as that. Get it now? So try to take your time to watch this video several times if you don't understand. So if you watch it several times, you have a better understanding of what I just did here. Do you understand? Alright, so we have to express 214 base 6 minus 1011 base 2 as a number in base 6. This might confuse you, but don't get confused. Just watch me. So the first thing we'll do is this one, we'll convert it to base 10 by multiplying by the base, which is 2. So whatever you get, you now divide it by base 6, after which you now would subtract it by this one. So let's do that now. So let's multiply this one now. So we have 0 1 2 3. Have you seen that now? So that is 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2. 0, 1, 2, 3. 1 times 2 raised to the power 3 is 8. So this one is 0. So you don't need to bother yourself. 1 times 2 raised to the power 1 is 2. 2 raised to the power 0 is 1. So that is 1. So when you add them up, we have this one is 2. This one is 1. So this is 11 base 10. I think that we don't need to put the base. So now we've gotten 11. You get it now. So now 11 now, you now divide by 6, which is the base here, 6, so it can be equals to this. So this is 11 divided by 6 is 1, remainder 5. So 6 again, 1 divided by 6 is impossible, just write 0, remainder 1. This is 15. So we can now go on to what? In base 6, we can go on to subtract it from this one now. So we have 214 base 6, subtract it from here, from 15 base 6. So have you seen that now? So 4 minus 5 is impossible, right? So now we are going to borrow from here. When you borrow from here, this one turns to 0. So you add the 6. I told you that when you are borrowing the base. So now this is it. 6 plus 4 is 10. Okay? 10 minus 5 is 5. So you've already borrowed from it, so it has been reduced to 0. Okay? So 0 minus 1 is impossible also. So you borrow from here. When you borrow from here, this one will be reduced to 1. So you move what borrowed to this place, which is 6. Okay? So 6 plus 0 is 6. 6 minus 1 is 5. So we've already borrowed from here, so we have 1. So that is our final answer. Okay? Of this now. 10. If 132 base 4 equals to x base 8, find x. So the first thing we are going to do is we are going to multiply this one by the base. So wherever you get, you divide it by 8. So wherever you get, after dividing by 8, means this x. So let's go. So we have 132 base 4, 0, 1, 2. 1 times 4 plus 3 times 4 plus 2 times 4. 0, 1, 2. 4 raised to the power 2 is what? 16. 4 raised to the power 1 is 4. 4 raised to the power 0 is 1. You already know that. So we have 16 plus 12 plus 2. Have you seen that now? So 2 plus 12 is 14. 14 plus 16 is what? 30. You understand? So that's for that. So wherever we get now, we divide by this base. So we can get our x. So now let's divide by 8. So now 30 divided by 8 is what? 3, remainder 6. So now 8. 3 divided by 8 is what? 0, remainder 3. So we have 36. So this is our x. So this is in base 8 now. So this is our x. So we now have 1, 3, 2. So we now have our x to be what? 36. So now that is how to solve that now. So that feeling bored, you don't need to just take a popcorn and hit it. Do you understand? So now let's do this one now. If 43 base x equals to this, so let's find x. So now we'll first multiply this one first by the base, then you multiply this one by the base. Get it now? Then you now equate them. So this is 0, 1. So we have 4 times x plus 3 times x. Okay? Are you seeing that now? So we have 0 and 1. So this is x raised to the power 1 is what? X. So we have 4x plus 3 raised to the power, x raised to the power 0 is 1. So 3, that 1 times 3. So we have this. So this is for that. So let's go on with that. So let's move to this one now. So we have 0, 1, 2, 3, 4. If you do this one, you have a better understanding. You won't be confused. So we have 1 times 2 plus 1 times 2 plus 1 times 2 plus 1 times 2 plus 1 times 2. Okay? So we have 0, 1, 2, 3, 4. Alright, so we are on the same page, right? So 1 times 2 raised to the power 2, 2 raised to the power 4 is 16. 1 times 2 raised to the power 3 is 8. 2 raised to the power 2 is 4. 2 raised to the power 1 is 2. 2 raised to the power 0 is 1. Okay? So we have 16 plus 8 plus 4 plus 2 plus 1. So let's add them up. 16 plus 8 is 24. 24 plus 4 is 28. Plus 2 is 30. And plus 1 is 31. Okay, so what are you going to do? I'm going to equate the answer. So let's equate the answer. So we have 4x plus 3 equals to 31. So let's collect like terms now. 4x equals to 31. When you bring this one here, it turns to minus, okay? So this is 4x equals to 28. Are you seeing that? Now it's very simple. So you divide through by 4. So our x equals to 7. It's as simple as that. So we are done with that now. So now let's move to the final subtopic. Alright everyone, so the next subtopic is application of binary system. So this involves punch cards. You get it now. So the binary system is a number system that uses only 2 digits. We're not talking about binary system, we're talking about base 2. So the digits are what? 0 and 1. Get it now. So now, just like a switch, on and off, on and off. A punch card can be used for collecting and storing information in a very economical way about people or things. Get it now. So when you talk about punch cards, they are used for collecting and storing information in a very economical way. Talking about talking about information of people, information of what or things, and they are usually written in binary codes. So now the diagram below, I'll be drawing the diagram after this now. So the diagram below is an example of punch cards in which a hole punch. So just like when you have, when I create a hole here, that hole when I punch it represents 0. You understand? And a slot out stands for 1. The slot out starts for what? 1. That was not when I punch it. When it slots them out, it starts for 1. The card contains information about a student. I'll be drawing the diagram very soon. The card contains information about a student whose name is X Aneke. If 1 stands for a subject he likes, 1 stands for a subject he likes, and 0 stands for a subject he does not like. When I draw the diagram, you have a better understanding. Then the binary code for the subject he likes will be 01101. I'll show you the diagram. So starting at the extreme left, the card tells us that X and AK does not like history, likes math and science, does not like science, does not like arts, but he likes technical drawing. So let me draw the diagram so that we have a better understanding. Okay now, so while I was displaying this, I promised to draw the punch card. So this is the punch card. You understand? So this is a punch card. So now it said if 1 stands for, so this is the hole now. So the hole stands for 0, while the slot stands for 1. So now this O is when you don't like a subject, while the slot means when you like a subject. It means 1. So now I said for a subject he doesn't like, then the binary code for the subject he likes will be is 0. So this is the O now. So this is 0, 1, 1, 0, 1. So that's why we have 0, 1, 1, 0, 1. The O represents 0, the slot represents 1. So that's for that. So now let's go to this example now. Let's go to this example. So this example says, using the cards in Aneke's class above earlier, write down the subjects liked by students whose card represents the following binary cards. So now the first one is this 01101. So now 0 now. So it shows that history now, he does not like history. Subject liked, so only the like now is what we want to focus on. So he like math. So this is 1. Like math. So the next subject is science. So he like science. So the last one is technical drawing. So he like technical drawing. So have you seen it now? So it's as simple as that. So he has to pick the one that he likes. Get it now? So let's move to this one. Okay, B now. So we have 10010. So now this one, now the first one is history. So you like history. Okay, let's do it this way. Like history. So 1, 2, 3. 1, 2, 3, 4. So you like arts. So this one here shows that you like arts. So that's for that one now. So let's move to the last one. So the last one is this 01011. So if you look at this one now, the second one is math. So you like math. 1, 2, 3, 4. 1, 2, 3, 4. Have you seen it now? So you like arts. So why the subject that follows it is what? Technical drawing. So you like technical drawing. So that is just how to go about it. It's as simple as that. So it is simple, very simple. So let's move to the next subtopic now. Okay, so this is the continuation of the application of binary system. So talk about sending messages now. So messages can be sent using binary codes. So you can send messages to someone using binary codes. So now numbers written as series of zeros and ones are said to be in binary code. 1 and 0, they are binary numbers, you understand? So you can write this what 1 and 0s in binary codes. So now e.g. the numerical code for Q is 17. So this binary code is found by converting 17 to base 2. You get it now? So when you convert 17 to base 2, like 17 divided by 2, so wherever you get is the binary code for 17 for the Q. Now let's see, letters, numerical code, binary codes. So now the letter A represents 1, that's the number. So now this one, when you divide it by 2, you get this. You get it now? This 2, when you divide it by 2, when you divide it by base 2, you get this. So this, don't mind this is 0, you're just putting this 0 just for, to get it. So no, when 2 divided by 2 normally give you 10. So this is 0, you just put it normally because of what this subtopic is all about. So now this 3, when you divide by 2, you get this. Same with this one, when you divide by 2, you get this. 5, when you divide 5 by 2, you get this. When you get divide 6 by 2, you get this. Especially the last digit numbers, that's what you get when you divide all this one. So the last numbers before the last numbers after the zeros gives you is what this number will give you. So now 8 divided by 2, you get 1000. 9 divided by 2, you get 1001. You get it now? So now let's move to the remaining one. Let's finish it up. Okay, now, so this is the continuation of the alphabet, letters, numerical codes, and binary code. So this is J to Z now. So as I said earlier, 10 divided by 2, which is this. Base 2 will give you this. 11 base 2 will give you this. 12 base 2 will give you this. 13 base 2 will give you this. So till you get to 26. So 26 base 2 will give you this. You get this now? So now let's quickly solve an example so you have a better understanding of what all these things. So now they said using the above binary codes, like all those numerical codes, binary codes that we did previously, send the message I like maths. So now this guy are going to tabulate it. Messages, numerical codes, binary codes. So other messages, this alphabet will be there. So to be I. So just want to use this line to separate them. I like maths. So you just put the numerical codes of what all these things represent. So you know what I represents. So you are going to put the numerical codes. So you know I, you know what it represents. L what it represents. I, K, E. Then the binary codes. You get what? You can just check or you can just put them off out. See, the most important thing is this. It's very easy. I, what is I? You already know what I is. Divide by 2. So wherever you get, you just put it here. Do you understand? So let me play with that. Alright, now to avoid this video more elongate and what's it called, longer than this. I don't want this video to be longer than this. So that's the reason I have to quickly write out this thing. So if I peradventure in your exam or I want to quickly get this, there's no way you copy, it's not possible. So what you do is this 9, don't divide by 2. Get it now, divide by 2, 9 divided by 2, and so just say 4, remainder 1, 2 divided by 2, 2, remainder 0, 1 divided by 2, 1, remainder 0, we have 0 remainder 1. Get it now. We have 1 0 0 1. It's this one. So we have 1 0 0 1. So with this one. So that's how we got this one. You get it now. You just add a 0 at the back. Once you are done writing this one, just write a 0 here. You understand? To make it 5. They have to be 5 digits. You observe the binary codes are what? They are 5 digits. So that's how to go about it. They are very easy. So now let's move to the subtopic. Now the next subtopic, which is a final subtopic now, is punch tips. Punch tips. So now, one way that some computers receive instructions an information by using a punch tape. A punch tape consists of a series of punch holes and blank spaces. Look at the diagram. We have series of what? Punch holes and blank spaces whereby we don't have any punch, any hole at all. So a punch hole stands for 1. So this one now stands for 1, while the blank space stands for 0. So now where we didn't write, when we didn't put holes, stands for 0. So now these sides, they have what? 2 space. These sides have what? 3 space. Get now? So we can only write 2 digits here, and we can write 3 digits here. So when we look at G now, G represents how many pieces? So there's nothing here. So we have 2 empty space. So we have 0, 0, 1, 1, 1. Do you get it now? 0, 0, 1, 1, 1. So that's what G represents. So now O represents, okay, we have what's it called? The space here is what? 0. We have 0. We have 1 hole here. And we have 3 holes here. Are you seeing that now? So now the next one is 0. Same with this one. Since we have 1 space here, but we have 1 hole here. So we have 0, 1, then 1, 1, 1, 1, 1, 1. Are you seeing that now? So the next one is now for D. So this space here is only what? They have 2 spaces. There are 2 spaces here. So it means it will be 0. So that's 0, 2 zeros because the spaces here are 0. And we have 1 here. Then 2 zeros because we only have what? No punch cards here. No punch, no hole here. So the next one now is G. So this is G. This is G now. So this is what G represents. So now this space now is 0 and it is 2. This one is 1. 1, 1, 1. Then the next one is R. Are you seeing it now? So we have 1 here. We have 1 hole here, but we don't have it. So we have 1, 0. So this one is now 1. This one is what? 0 again. Then we have what? 1 hole here, but we didn't have any hole here. So the next one is A. So now we have what? 2 space here. So we have 0, 0, 0, 0. This will be what? 0, 0, 1. 0, 0, 1. Okay. So now the next one is what? D. So just watch it carefully. So now this D now, see, no hole here. So it is 0, 0. So we have 1 here. And we have 0, 0. Get it now? Ensure that all those digits are up to 5. Once they're up to 5 there, they are good to go. So this is the last one. Space now. 2 space. So we have 1 here, 1 O. This one is empty, which is 0. And this one is what? 1. So that is how to do about this. As I've said earlier, this is the final subtopic. So now you can just rewatch the video for you to have a better understanding of each subtopics in this particular video. Get it now? So I'm so sure you understand everything I've done. This video looks like a marathon video, but it's actually worth it. If you watch the video from beginning to the end, I'll show you have a better understanding of what a binary number system is. You'll be able to solve it on your own without the help of anyone. Thanks for watching.